Hey guys, welcome back to my channel. So I will summarize the chapter 8 version 2.0. So the chapter 8 is entitled Subnetting IP Networks, Network Segmentation, Broadcast Domains. In an internet LAN, devices use broadcast to locate other devices and services. A device uses Address Resolution Protocol or the ARP, which send layer to broadcast a known IPv4 address on the local network to discover associated MAC address. Services a host typically acquires in its IPv4 address configuration using the dynamic host configuration. Octet boundaries. Every interface on a router is connected to a network. The IPv4 address and subnet mask configured on the router interface are used to identify the specific broadcast domain. Networks are most easily subnetted at the octet boundary. Creating subnets with 16 prefixed. In a situation requiring a larger number of subnets, an IPv4 network is required that has more host bits borrow from. Although a complete memorization of the table is not required, it is suggested that you gain a good understanding how much value in the table is generated. Subnetting based on host requirements. There are two types of consideration when planning subnets: the number of host addresses required for each network, and the second one is the number of individual subnet needed. The number of host addresses required in the largest subnet will determine how many bits must be left in the of host portion. Subnetting based on the host requirements. Traditional subnetting waste addresses. Using traditional subnetting, the same number of addresses allocated for each subnet. If all the subnets have the same requirements for the number of hosts, these fixed size address blocks would be efficient. However, most often that is not the case. Although this traditional subnetting meets the needs of the largest LAN and divides the address space into an adequate number of subnets. Structured design, network address planning. Planning network subnets requires examination of both and the needs of organization network usage and how the subnets will be structured. Performing a network requirement study is the starting point. This means looking at address plan includes determining the needs of each subnet in terms of size. Planning to address the network. Three primary considerations for planning address allocation are displayed in the figure. Let's go to the figure. So these are the three planning address. They prevent duplication of addresses. Monitor security and performance. Provide and control access. Providing and controlling access refers to the fact that some hosts, such as servers, provide resources to the internal host. Subnetting and IPv6. The IPv6 Global Unicast Address. IPv6 subnetting requires a different approach than IPv4 subnetting. The same reasons for subnetting IPv4 address space in order to manage network traffic also apply to IPv6. IPv4 subnetting is not only about limiting broadcast domains but is also about managing address scarcity. Subnetting using the subnet ID. The 16-bit subnet ID section of the IPv6 Global Unicast can be used by organization to create internal subnets. The subnet ID provides more than enough subnet and host support than will ever needed in one subnet. Create to 65,536 over 64 subnets. This does not include the possibility of borrowing any bits from the interface ID of the address. Support up to 18 quintillion host IPv6 addresses per subnet. IPv6 subnet allocation. With over 65,000 subnets to choose from, the task of the network's administrator becomes one of designing a logical scheme to address the network. Similar to configuring IPv4, that each of the router interfaces has been configured to be an IPv6. So for the whole summary of this chapter 8, this chapter 8 is entitled the Subnetting IP Networks. Every network address has a valid range of host addresses. All devices attached to the same network will have an IPv4 host address for that network and a common subnet mask or network prefix. Traffic can be forwarded between hosts directly if they are on the same subnet. Traffic cannot be forwarded between subnets without the remote. The router uses the subnet mask. The prefix and the subnet masks are different ways of representing the same thing, the network portion of an address. IPv4 subnets are created by using one or more of the host bits as network bits. Two very important factors that will lead to the determination of the IP address block with the subnet mask are the number of subnets required and the maximum number of hosts needed per subnet. There is an inverse relationship between the number of subnets or the number of hosts. The more bits that are borrowed to create subnets, the fewer host bits that are available. Subnetting a subnet or using variable length subnet mask or VLSM was designed to avoid subnet wasting addresses. IPv6 subnetting requires a different approach than IPv4 subnetting. An IPv6 address space is not subnetted to conserve addresses. Rather, it is subnetted to support a hierarchical or logical design of the network. So while IPv4 subnetting is about managing address scarcity, IPv6 subnetting is about building an addressing hierarchy based on the number of routers. Careful planning is required to make best of the available addresses space, size, location, used, and access requirements of all considerations in the address planning process. After it's implemented, an IP network needs to be tested to verify its connectivity and operational performance. So, for this whole chapter 8, we understand all the subnetting masks like how many prefix like that. You see the some examples like that. So for this chapter is we determine if traffic is local or remote, like that. The router is so very important. So while the IPv4 subnetting is about managing address scarcity like that, so that IPv6 subnet is about building and addressing hierarchy based on the number of routers and the network they can support. So that's all for my video. Thank you for watching. Please like and subscribe my channel. That's all.